Today's use case is quality prediction because achieving quality excellence is a multidisciplinary responsibility of the entire organization. To control the process within quality boundaries and analyze issues, manufacturing facilities continuously collect and store a large volume of sensor data, which subject matter experts utilize day in and day out. However, due to the sheer volume of data, only a small fraction is typically used in driving day to day decisions about operations. Statistically speaking, data is grouped into two main categories: numerical and categorical. Quality data mostly falls into the realm of categorical data of two levels: on spec data and off spec data. Even numerical quality data such as viscosity, molecular weight, or assay can still be broken down into categories of on spec or off spec data. However, plant data, on the other hand, is generally numerical in the sense that field sensors such as pressure, temperatures, and flows are generating time series data on a continuous scale within a given range. So basically, if we trend quality data with the process data, then we can solve more and more problems, and that's what trend miner allows you to do. You can bring quality data from different limb systems to trend miner, and you can trend it with the process data. Another point here is that lab analysis is done a few hours after the process is done, so there is a time shift in that data. So to find right correlation with process and quality data and build a predictive model out of it, it's really crucial. This becomes really hard if subject matter experts they don't have right tools. So I'm going to show you a quick way of building a quality soft sensor predictor here. So in this case, we have a pharma grade material, and you know that the pharma grades are very quality specific. So if quality isn't right, the whole material has to be flushed out. A team needs to clean the entire system. So these are some challenges here to predict the quality in advance and set up some kind of alert so that team gets alert when suboptimal product is about to be produced. So these are the challenges here. The first one is to find out the right correlations, and then maybe we can set up some kind of a quality alert to monitor the process. Okay, so let's go to the trend miner and take a look at this use case. So here we have product quality dashboard. I can directly take it to Trend Hub where we can analyze the data. So as you can see, it's quality data, and we are recording this quality data every 4 hours. So basically whenever batch or like product is completed, then they take the sample and analyze the data and record the results. So that's basically a 4-hour time shift here. So we will run recommendation engine to find out what other tags are highly correlated with the quality. And since we are doing analysis around this TMQSS asset, I can just search correlation around this asset. And as you can see, I have already provided a filter expression here, TMQSS. So I can save it and run the correlation engine here. And as I run the engine, you can see TrendMiner quickly provides us some correlations here. And as we look at the correlations, the first one is a lab data, which is kind of copy of this tag. That's why you see very high correlation. But if I look at the flow tag here, then flow is inversely correlated and temperature is around 15% correlated. So the correlation is not very high. But let's look at the flow here. So as you can see here, flow is making inverse correlation. And then if I add temperature, so temperature wasn't making any correlation up until the halfway, and then it starts making some correlation. That's why we see correlation percentage is 15%. So now we know that these two tags are highly correlated with the quality. So we can predict basically quality using these two tags. So that's what I'm going to do. I'm going to build a simple model here to predict the quality using these two tags. And for that, I'm going to use influence factor, which is located right here. So it's another correlation tool. It just runs on one layer, and it can detect the time shift as well. So in this case, I'm going to select the quality tag, and I'll go to the advanced settings and In the time shift, I'm going to select 4 hour because as I said, that quality is 4 hours shifted, or we are recording quality after 4 hours of the when the product is being made. So let's save it and analyze the data. And as we start analyzing the data, we see that it gives us flow and temperature here. And temperature percentage is very less because we have an empty model here, as you can see here. So I can add flow to this empty model and see what other correlations come. And we can see here now temperature's correlation is pretty high because the flow is in the model already. So model is considering flow and then it reruns and gives a higher temperature correlation. So I can add this temperature here as well. And now you can see the R square becomes 95% and then model is predicting quality pretty well, as you can see here. So we can save this model and give it a name, quality soft sensor 1. So now we have this quality soft sensor tag available. And now we can basically, we can go to the formula tag here, formula tab. And then maybe I can just take a difference between these two and create a monitor. So that's how we can easily build these. So in the simple alert, we can take value-based search and quality soft sensor. And when we can say whenever my quality soft sensor is, let's say, less than 85 and say my flow is greater than 10, meaning my flow is flowing for at least 10 minutes, then send me an alert. So in this case, we couldn't find any result. Maybe the flow condition is not right. So let me just delete the flow condition and run this again. And as you can see, I see 2 results here. So whenever my quality is less than 85, then Trend Miner is going to send us an alert when we save this search. So I'm going to just say quality or suboptimal quality. Suboptimal quality. Then I can go to the monitoring tab and I can enable it. And I can provide my information to get the email message, like my email address, subject, etc. And then we can save this alert. In this case, I'm not going to do that. So I'll just save it. So basically by doing that, we can actively monitor the quality parameters using other parameters like flow and temperature in this case. And then we can gain quality improvements compared to the previous month or compared to the previous year's production. So that's what I wanted to present. Thank you.